Alright, so the final thing that we're going to want to do is we're going to want to create a function that we can use a root solver to minimize. This is that delta H is, enthalpy in minus enthalpy out. So we have our function for enthalpy. We have the amount of moles that we have of each of the components. So we kind of need to combine these so we know exactly how much is going in versus going out. So to do that, we are going to define a function. We can call it enthalpy solver, because this is what we're going to use to solve for the, or maybe that's too long. We'll just call it equation. So we'll define equation, and we want to import a vector. It's important that this is a vector because root solver is going to look for a vector, because it's set up to solve, systems of equations. So you have, multiple equations, multiple unknowns. We only have one equation here, but it still needs to be within a vector. So we're going to factor a vector into temperature, because that's what we wanted to solve for. We wanted to solve for temperature. So, and then we're just going to return our enthalpy. So this also needs to be returned as a vector. And so the first thing, we're going to have final minus initial. So what's our final? So our final is going to be the enthalpy. So enthalpy of temperature, and then we're going to want to multiply this by the amount of moles, but we can't just do like a regular multiplication sign because this is an array. So we're going to actually do a dot product. So np dot dot of that got extra parentheses in there. Alright, I think I got my parentheses sorted now. Alright, so it's going to be np dot, and then it's going to be the enthalpy, and we'll multiply that by the moles going out, because that's like our final situation, is as it's exiting in the higher temperature. So we're going to use moles out, and then so that's our first term, and then we're going to subtract that by np, so dot product again, but this time it's going to be our enthalpy at 298, dot product with our moles going in, because this is like our initial situation. And so yeah, do I have all of my parentheses sorted? Yep, I think I do. Alright, so shift enter on that. So that's the function that we're going to want to minimize. So let's go ahead, get the root solver. So we're going to take root, and we're going to take, equation, and then we have to give it a guess. So let's say maybe 2000 Kelvin, because it's going to be pretty hot. It's a flame, right? So we get that, and we see down here, this is our, this is where the solution is 0, because root minimizes functions. So if we want to pull out just this, so we can do dot x and then grab the first term of that array, so like that. Pull out this. So this is what the temperature of our flame is going to be. And, we could put this inside of another variable if we wanted to use it for further analysis, further problems. We don't need it for this problem, so I'm just going to leave it there. But yeah, so the temperature of our flame is going to be about 2063 Kelvin.